Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So now we move on to talking about determining molecular formulas. And so here I want to go over moles and molar mass one more time, as well as a definition of each, just so that you get a better understanding. So the definition of 1 mole is the number of atoms in exactly 12 grams of carbon-12. So this is kind of the standard element. And so 1 mole of objects always means 6.022 times 10 to the power of 23 of those particular objects. And this is called Avogadro's constant or Avogadro's number. Molar mass is the mass per mole of particles, and we talked about this in previous parts, but the mass in grams can be found from the number of moles times the molar mass, which is in grams per mole. So now we're going to talk about determining the molecular formula, but in order to do that, one other important thing that you need to know is empirical formula. So empirical formula shows the relative number of atoms. For example, CH2O for glucose. This just means that for every 1 carbon, there's going to be 2 hydrogens and 1 oxygen. It just shows you the relative numbers. But when we talk about the molecular formula, now glucose is written as C6H12O6. It's still the same molecule, but now it shows the actual number of the atoms. So now instead of the 1 to 2 to 1 ratio, we have 6 carbons, 12 hydrogens, and 6 oxygens. So we need to know how to calculate the mass percentage composition and empirical formula in order to take the next step, which is calculating the molecular formula. Okay, so now I'm going to show you an example of how to calculate molecular formula.